Well, hello guys and welcome back to the channel. Today I'm going to show you how to create a curve modifier but with nodes. Probably we're going to get this node too sometimes, but for now we need to resort to something like this. You can download this node from the link in the description. It's not free, it's $2, but it's a way to support this channel and my work on this channel. And if you don't want to download it, you can watch me recreate it or go through all the passages to recreate your own. Anyway, first I'm going to show you how it works, and then we're going to go over all nodes inside of it so you can recreate your own. So let's begin right away. So here we have a Bezier curve. And we have our geometry nodes enabled, and we're just gonna add our curve deform node right in here. But we need to connect our geometry, which is a Bezier curve, to the curve option. Let's just sever this one. Okay. And nothing happens. And why nothing happens? Because we don't have an object to put on our curve, let's call it. So let's just add our cube simple. I think this is the one. Okay, and we're just gonna connect it to the object right here. Okay, and first you can see that something happens, but it's not right, because the first thing we've got here is our X, Y, and Z axes. So right now we got one selected here, so it's let's say it's using the x-axis to realign this shape onto our curve. So this is the x-axis, so it's practically aligning it in this direction. But we can change that right away by selecting 2. So 2 is our y-axis, so y-axis goes like this, and now it's getting aligned right on the y-axis like this. What we have next, you can obviously use also the z-axis, and so it gets aligned like on this. So our object gets aligned like on this axis, but we don't want that. We want our y-axis like this. Perfect. So the next parameters we have is rotation. As you can see, you can rotate it as much as you like. You have the offset, so you can offset it a bit. You've got the elevation, up and down movement, or start offset, so you can start from another point of the curve, as you can see, not just the first point of the curve. And then we have the subdivide mesh that helps you when you have like objects with low geometry, so it doesn't nothing happens. And that is practically it. Oh, and of course you can reverse the curve, so you can start from the other point of the curve and go the other way around. And that is practically it. So this is how this group node works. And now I'm gonna go into our test explanation, and we're going to show you how did I create this, right? Okay, let's begin. So this is my curve deform modifier, but here I did some modifications just so that you can understand better. For example, this curve object, this node doesn't exist. It's just connected to the object right here, so you can plug it from the outside. But for our purposes, we need to connect some object, because otherwise we will not see what's happening. So here we have our cube simple, and as usual, Shift Alt to connect the selected node to the output group, so that you can see what comes out of the node you've selected. So out of this, obviously it comes out just our object. Okay, so this group node is another group node of mine that I created, and it practically centers your object to the geometrical center of it. So for example, if our object here, let me just open our object here. If our object here, if we go into like this, and if we were to move it somewhere like this, as you can see, nothing changes in this because it centers it. As you can see, the origin point is really outside. It's really outside of our object, of our geometry of the object, but here it's still in the center. If we see what comes out of this node, you can see that it comes out with this, just like with not centered. And then after we pass it through this node, it goes back into center. And why? Let's go check it out inside. So I went into this node. It's pretty simple. You just use your object statistic. You need to find your x, your maximum x and minimum, your maximum x, y, z values as your minimum x, y, z values, and with a bit of geometry, you just transform or you move your object where it needs to go, just like this. So that's how I done this. So now whatever and wherever our origin point of the geometry is, from this geometry node on, it's going to be in the center. Okay. Right, let's move on. So here we have that subdivide mesh here, that subdivision. That's if you want it, you can subdivide it more and more or not, whatever, but you have that option here. And then let's go here. So this is our first transform node, and here what we've done, we placed our object just like we placed here our center at the center. Here we placed our geometry somewhere so that our center is at the beginning of our object. But this beginning of our object changes in respect of whether we want to align it on the x, y, or z axis. So if we have, like here, 1, so we want our x axis to be, so we look at our object, and then as you can see, our x axis, so the lowest x value is where our origin point is going to be. If we set it to 2, so our y-axis, so the lowest y value is where our origin point is going to be, or the z, and now we need to go into our, I don't know, the lowest z value is where our origin point is going to be. And here is how I did that. So I'm translating it depending on this value, 1, 2, 3, and here I'm using another group that I created, and it's I called it 1, 2, 3 vector switch. So if here is 1, then it returns this value. If here is 2, it returns this value. If this is 3, it returns this value, and this works practically as a switch, but instead of like 1, 2 switch or 0, 1 switch, we have 1, 2, 3 switch. It's pretty simple, and I will show you what it's like inside. It's not that complicated. We just have these values 1, 2, 3, and we have 2 switches. And with a bit of math, it returns 1, 2, or 3. And but what are these? And these are the vectors we need to move our object in order to have it positioned the way we want it to be positioned. And obviously we need to know the minimum values of our x, y, and z component, so that it's also practically simple. We need our object and our attribute statistic. What attributes do we need? And now here is another different story. We need different attributes depending on this value 1, 2, 3. So if we have 1, we need our x value. If it's 2, we need a y value, y attribute, and if it's 3, then we need our z attribute, so z position. And so I used another group 1, 2, 3 float switch. So this is a vector, and this is a float. It's simple. It's just like the other one, but here we have 1 values instead of 3 values. So 3 values are vectors, and 1 value is just that 1. Okay, so if we have 1, then this value comes out, and the 2, and this, if we have 3, then it returns this value 3. And so we are looking at the attribute, the minimum y value, the minimum x value, and the minimum z value, and then we will change its, if it's negative, it's going to be positive, and that's the value. We're going to move it with this node by using these 3 vectors. We have these 3 different vectors because if the value is x, we need it in x, y, or z, depending on the 1, 2, 3 switch here. Okay, so this is what we've done here. Let's place it back on the y, because that's why we want to move it. And then we got our transform node that rotates our object, and it will rotate it exactly this amount. And still, again, we need this 1, 2, 3 vector switch, because depending on this, we need to rotate it. Nothing if it's 0, 90 degrees on the z axis, or 90 degrees on the y axis, depending on which axis do you need here. See, okay. And then we have another transform, and this is the different rotation that we set here. So this is, if we on the z and on the y, it's like this. That's what we see in that beginning of the video that I showed you. Okay, let's set it back to 0. Okay, then another transform here, and here we offset it. So we offset it on the z-axis, connected to the socket here. So when we move the offset, it goes up and down, right. Then another transform that elevates it. Same thing as here, only on a different axis. And the last transform here is that start offset. So remember, if you don't want to start it at 0, you can just move it like this, and it will do exactly what it's supposed to do. And then we've got the mother of them all, the last node. It's a set position node, and this last node is what actually makes the transformation. And this one is gonna get a bit complicated, but we're gonna try to do it anyway. So just like the object here, the node actually looks like this. But for the sake of this tutorial, I've added an object node here, and I selected our Bezier curve, which is the curve we had here. Remember, it's this curve right here. So you can select it also. And first things first, the reverse curve. This is the reverse option, the reverse switch. So pretty self-explanatory. If you want it reversed, it will return this. If not, it will just return this one not being reversed. Okay. And now we have the sample curve node. And this node, it samples from the x coordinate of our objects. Why is that? So let me just go back here. So we set our object like this, so that it's running like parallel to the x-axis, because if it's like this, it still runs parallel to the x-axis, and if it's z, it will still be running across the x-axis, along the x-axis. And so what happens here? So this node here contains the values of all these position values for all these vertices. But we need just the x. And why is that? And we're using this sample curve so that the x position of all these vertices will be connected to the length of the curve. So if the curve runs like this, and here the length is 0, but here the length is, I don't know, 1, then here is the length is 2, the length is 3, 4, okay. So I want to connect these x values. So this vertex has the x of 1, this vertex has the x of 2, and so on. And I need to connect it somehow to these values. So this, what does this node do? At the point of length x, it returns a position, a tangent, and a normal vector. So what does this mean? So for example, at this point right here, the length of 1, it will return the position of this vertex, this position exactly, and the tangent, that's going to be this vector, and the normal, that's going to be this vector, and so on. So at length, I don't know, 8, this is going to be the position that's going to come out here, the tangent, and the normal. Okay, so that's what we needed. So what did I do with this set position? You have this geometry position, and then I added to the position of the curve. So practically all these vertices at the start of the curve where the x is 0, so at the curve start the length is 0, I said, okay, that's the position I want to start with. So that's the position all these vertices I want to be. So if there was no vector here, if I just was to connect this to this, practically all these vertices would collapse along this curve like this. But these 4 vertices would be here, and I don't know, the last vertices, these last vertices here would be exactly how long is this on the x-axis, how long is this, so probably somewhere around here. So all these vertices would be collapsed under at the same position here. Okay, so now with this, but we need to add something else, so that these 4 vertices, one of them needs to go here, the other one needs to go here, other one needs all these 4 vertices need to go somewhere around here. And what's the value of these movements and these vectors? Well, that's practically the position, the coordinate of the z and the y, right? Because x, okay, we solved the x, but z and y are these coordinates right now, if you can know what I mean. So how do we move these collapsed vertices that are all collapsed in this one point? So we need to add that vector to that position. We're going to use the tangent and the normal, because we have the tangent and we have the normal. So this here is the component y, the y component, and this here is the z component, and it needs to get multiplied, the y component, with the cross product of the tangent and normal, and the z component needs to get multiplied with the normal vector. And then we need to add these two vectors, and their sum is going to be the vector that you need to move all these points respectively on their x and y values. And I don't know if you got the explanation. Hopefully you did. But anyway, if you didn't, this is the node tree you need to recreate, and it will work. I promise. Okay, so guys, that is practically it for today also. Thank you very much for watching. Remember that you can purchase this file or this node from the link in the description, and I will talk to you in the next video. So see you next time. Bye bye.